Hello and welcome back to the course
Fundamental of Electronics and Electrical Engineering.
The topic that I am going to discuss in this video lecture is a network theorem, and one of the network theorem, that is Thevenins theorem. Now we know most of the circuit can be solved using series and parallel connection of the resistance and star delta transformation. But when the circuit is complex, then analysis of the circuit using star delta transformation and series parallel connection of the resistance becomes lengthy. There are certain techniques using that we can speed up the analysis of the network, and these techniques are nothing but the network theorems. Using network theorem, we can speed up the analysis of the given network. And one of the network theorem I am going to discuss in this video lecture is Thevenins theorem. So let us start. What is the statement of Thevenins theorem, where it is used, and which is the procedure, how we can solve the given network using Thevenins theorem. Thevenins theorem is used to calculate the current through an element or voltage across an element in the given network without calculating current and voltage of the remaining branch of the network. Now what is a statement? It states that in a linear bilateral active network, the current flowing through an element can be found by replacing the remaining part of the network by a voltage source VTH in series with equivalent resistance RTH. Now what is VTH and RTH? Linear means what? The element for which VI characteristics remain same. Bilateral means what? Resistance is a bilateral network in which current flows in either direction, and current can flow in any of the direction. And active network means what? We already know what is active element, the element which consists the energy sources. Now linear active bilateral network is there. In that network we can find the current through an element by replacing remaining part of the network by VTH and series RTH. Now what is VTH? It is a Thevenin's equivalent voltage. It is an open circuit voltage measured between two terminals at which the element was connected, the element in which we have been asked to determine the current. RTH, it is known as a Thevenin's equivalent resistance. It is the equivalent resistance of a network when looking back into the network from open circuited terminals after replacing energy sources by their internal resistances. Now VTH and RTH will be clear to you when I will take one example. So this is the given network. The network is divided into the two parts. One part is left hand side of the AB terminal and other is the right hand side of the AB terminal. The network RL in which we want to determine the current. So we do not need to find the current in the remaining part of this network. Now this network can be replaced in terms of VTH and RTH. That is, this part can be replaced in terms of VTH and series RTH. And after finding the value of VT and RTH, we have to connect the network RL back and we can easily find the value of IL, because now this network contains only one loop. Initially the network was having number of loops. Now we have converted this complex network into the simple network which consists of only one loop, and we can find out the value of IL by applying KVL in this loop. Now this combination of VTH and series RTH is nothing but the Thevenin's equivalent circuit. So first we have to replace this part into the VTH and RTH, and then we have to connect RL back and we can easily find the value of IL. So let us take one example, then Thevenin's theorem will be clear to you. So suppose this is a one circuit which consists of two loops. In this circuit, suppose we have been asked to determine the current flowing through RL. So step 1 is what? Step 1 is to remove the branch in which you have been asked to find out the current. So here we want to determine the current through RL. So first remove the RL. If we remove the RL, network loop will look like this one. Now we have to find out the VTH, that is a Thevenin's equivalent voltage. Now there is only one loop, so current I will start to flow. Now determine, second step is VTH, determine VTH. Now VTH is determined between the open circuited load terminals. So we have to determine VTH between terminal A and terminal B. So VTH will be what? VTH is across R2. So VTH will be equal to I into R2. Now but I is what? So to find I, we have to apply KVL in this loop. There is no division of I because this is an open loop. So all the current will flow in this loop. So I is equal to E divided by R1 plus R2. So VTH is equal to E divided by R1 plus R2 into R2. So this is how we can determine VTH. VTH is always determined across the open circuited load terminals. Now next step is a determination of RTH. Now to determine the RTH, we have to replace all the energy sources in the given network by their internal resistances. So voltage sources are always short circuited and current sources are always open circuited whenever we are determining the RTH. But as this network does not contain the current source, only the network contains the voltage source. So voltage source is short circuited. You can see here E1 is E short circuited. Now we have to look back from open circuited load terminal. So we have to find out R equivalent from right hand side to the left hand side between terminal A and B. Now we can see R1 and R2 now in parallel. So R equivalent becomes R1 parallel R2 and R equivalent is nothing but the RTH. So RTH is equal to R equivalent is equal to R1 R2 divided by R1 plus R2. So in the third step we have determined RTH. Now draw the Thevenins equivalent network. So we have determined VTH and RTH. So VTH and RTH are connected in series. So this is the Thevenins equivalent network. In some of the example, you have only asked to draw the Thevenins equivalent network. So this is nothing but the Thevenins equivalent network. Now we have been asked to determine the current flowing through RL. So now after we have drawn the Thevenins equivalent network, connect RL back to the terminal AB. So if this is the Thevenins equivalent network, now connect RL back to the terminal A and B. Now we can find out the IL easily because there is only one loop. So IL is nothing but the IL is equal to, if we apply KVL in this loop, IL is equal to VTH divided by RTH plus RL. So these are the steps to solve the given network using Thevenins theorem. First, remove the branch in which you have been asked to determine the current. Then find the voltage between open circuited load terminal, that is nothing but the VTH. In the next step, you have to find out the value of RTH. RTH can be found by looking back into the open circuited load terminal, but whenever we are finding the RTH, we have to replace energy sources by their internal resistances. Voltage sources are replaced by short circuit, current sources are replaced by open circuit. And finally, after VTH and RTH we are getting, we have to redraw the network, that is a series combination of VTH and RTH, and finally we have to connect RL back and we have to apply KVL to determine IL. So these are the different steps. This is how you can solve any network using Thevenins theorem, any complex network using Thevenins theorem. Now taking one example based on Thevenins theorem, so it will be clear to you. So here one network is given which consists of two loops. It consists of 50 volt battery and three resistors 10, 3 and 5 ohm. Now this network is very simple from the initial loop, but to understand how Thevenins theorem works, I have taken very simple network. Now in this network, we have been asked to determine current through 5 ohm resistance. So 5 ohm resistance becomes the load resistance in this case, the resistance in which we want to determine the current. So step 1 is what? Step 1 is remove the branch in which you have been asked to determine the current. So here 5 ohm resistance branch will be removed in the first step. So network will look like this one. Now RL 5 ohm resistance is removed. So current will be flowing only in this loop and that current is I. Now second one is determination of VTH. So to determine VTH, we have to consider the open circuited load terminals, that is terminal A and B. Now VTH will be across 3 ohm resistance. So VTH will be I into R2, but R2 is nothing but the 3 ohm resistance, voltage across 3 ohm resistance. Now we have to find the value of I. So we can find the value of I by applying KVL in this loop. So I will be equal to 50 divided by 10 plus 3, and that is nothing but the 3.84 ampere. So VTH is equal to 3 into I. So 3.84 into 3. So VTH is equal to 11.52 volt. Now next step is determination of RTH. Now remove the source of energy from the circuit. So as I already discussed, to find out RTH, we have to replace all the voltage sources and current sources by their internal resistance. This circuit does not contain any current source, it contains only one voltage source. So 50 volt battery is replaced by short circuit. So now the network look like this one. Now R equivalent can be found by looking back into the open circuited load terminal. So we have to find R equivalent from this direction. Now we can say 10 ohm and 3 ohm are in parallel. So R equivalent is equal to 10 parallel 3, that is 10 into 3 divided by 10 plus 3, that is 30 divided by 13, that is 2.30 ohm. So R equivalent is RTH is equal to 2.3 ohm. Now final step, connect back 5 ohm resistor between terminal A and B and find the current through it. So the value of VTH which we have got is 11.52 volt and RTH is 2.3 ohm. Now between these two terminal connect 5 ohm back. Now only one loop is there, so we can easily find out the current through 5 ohm applying KVL in this loop. So IL is equal to VTH divided by RTH plus RL. So 11.52 divided by 2.3 plus 5, so 1.57 ampere. So current flowing, you have to write that current flowing through 5 ohm resistance is 1.57 ampere. In this example, you have been asked to determine the current through 5 ohm resistance, that is 1.57 ampere. But suppose you have been asked to determine the voltage. So voltage across 5 ohm resistance is equal to 5 into IL, that is 1.57 into 5, that is 7.85 volt. So this is all about the today video lecture. In this video lecture, I have discussed about the network theorem, that is Thevenins theorem. I have also discussed how to solve a complex network using Thevenins theorem and discuss one example based on that. Hope you have enjoyed the video. See you soon in the next video. Thank you for watching.